He says, should you invest in an engine that is said to burn air at room temperature when you were told that a special chamber allows oxygen to combine with nitrogen to form nitrogen dioxide, oxide, using the reaction below? Now, this is what we are given. I told you I don't like balancing reactions this way. So in chemistry, we don't like making use of that half or all those kind of fractions. We like it to be whole numbers in chemistry. So using the principle, I ask myself, how many nitrogen do I have here? 2. How many do I have here? 2. How many do I have here? 1. So I carry the 2 and come here. 2. So I have 2 nitrogens now. The minute I bring these 2 here, oxygen is now 2 times to 4. So I put 2 here for oxygen so that it becomes balanced. So 4 oxygen, 2 nitrogen, 2 nitrogen. So balanced. Now the next thing is to bring down the values given to me for the end. Okay, they did not give me any value. They did not give me any value. That is why in a situation where you are not given any value, that is why you need to go and study the entropy and enthalpy of what's it called, elements. So the entropy of nitrogen is 191.5. That of oxygen at standard temperature and pressure is 205, yes, 0.0. Then this compound, the entropy of nitrogen oxide is 240.1 joule per mole per Kelvin. So if I know that, now the enthalpy, change in enthalpy of the enthalpy of pure elements is 0. The same thing with Gibbs free energy. The Gibbs free energy of pure elements is 0. Entropy cannot be 0. That's the third law. So the of nitrogen oxide dioxide, the enthalpy is 33.18 kilojoule per mole. So since I know this now, solving that second question, remember that this is exercise exercise 2 on page 14 of Newman chemistry. So freshman chemistry. So if I know this, I know that change in entropy is the same thing as saying sum of entropy of products minus sum of entropy of reactant. This is the same thing as final minus initial state function. So this is the same thing as saying, notice that here I have 2 of this nitrogen dioxide. So 2 into 240, that is value for entropy there, minus, here I have just 1. So this is the same thing as 191.5 plus, this is 2 oxygen, so plus 2 into 205.0. So when you do the mathematics, you have that this is going to give you 480.2 minus 191.5 plus 410.0. You have your calculator, punch your. So this is going to give you 480.2 minus 601.5. Punch your own. So when I do this very well, I know that this is going to give me, this value is greater than this, minus. So that is for entropy. And I told you that entropy is always in joule per mole per Kelvin. So I think let's do the conversion here so that it will be easy for us. So if we want to convert this now, this is the same thing as saying, if we divide this, okay, let me not convert yet because I have not multiplied it with temperature. But if I choose to, divide this by 1000. Know that this will now be moving this way, moving this way, moving this way. Okay, so I think which will give me 0.1213, but let me still leave it at this. Let me leave it at this so I don't confuse you. So this is minus 121.3 joules. So let's find the enthalpy. So for enthalpy, remember that the reason why we are doing this, the question said we should find change in H, change in S, change in entropy. So we've gotten change in entropy. So it's to get change in enthalpy now before changing Gibbs free energy. So change in enthalpy is going to be sum of enthalpy of products minus sum of enthalpy of reactants, which is the same thing as saying products. We have that the product is nitrogen 4 oxide, which is in this form, which is having 2 as its stoichiometric coefficient. So that is the same thing as 2 times 33.18, 2 into 33.18 minus the reactant part. I have everything on the reactant part. For nitrogen, is a pure element, is going to be 0, plus oxygen pure element is going to be 0. So minus everything here is 0. So this is the same thing as saying 66.36 minus everything here, which is going to give me 66.36 kilojoule per mole. So that is that. Now for Gibbs free energy, delta G, Gibbs free energy, all I need to do is just delta H using this formula minus TD, T delta S. And I told you that this means 66.36 minus, remember that temperature here is 298 Kelvin. At standard temperature pressure, the temperature we use is 25 degrees Celsius, which is 298 Kelvin, unless specified or otherwise stated. You can use any other value. So change in entropy is change in entropy is minus 121.3. So when you multiply this, you'll be getting minus 36,147.4. So it's at this junction that we divide by 1000. And when you divide this by 1000, you get minus 36.1474. So minus 66.36. So minus will change to plus. So add these two up. If you add it up, you have that Gibbs free energy is equals to 66.36 plus 36.1474, which is equals to 102.5074 kilojoule. That is my answer. That is my final answer. So let's look at it. This is the question. From the question, the interpretation, everything I have. This is my solution. So this is the question. And the first one. This is everything on the first one. The question for the first one, and this is the solution to the first one. The first one, this is the solution.